welcome everyone to As-Built Surveying Best Practices presented by Precision Property Measurements. So my name is Cameron Slatterbeck, as Mira mentioned. I'm the Regional Director for our Southern California office here at Precision Property Measurements. I've been with PPM for about 13, maybe 14 years now. I'm really seeing firsthand how the impact of technology has revolutionized the industry and the industry standards for creating as-built plans. So let's get started. First off, wanted to mirror what Mira mentioned. Quickly remind everyone that AIA Santa Barbara is the continuing education provider for this program. And so starting off with the course description, I'm going to run through this whole thing just to kind of get it started. But so As-Built Surveying Best Practices is a comprehensive course that teaches architects how to create as-built plans prior to beginning their design process. The class is intended to educate the attendee about both parts of the as-built survey process, gathering the field measurements of the structure, as well as using that data collected to draft or model the final plans needed by the architect. The first part of the course focuses on laser scanning, which is quickly being adopted as the main form of field measuring because of its efficiency and accuracy. The second part of the course explains the second step in creating as-built plans, which is to document those existing conditions using the point cloud in AutoCAD 2D drafting software and or various 3D BIM software. When attendees complete the course, they'll understand the full process of creating as-built plans, using laser scanning as the main method for gathering those field measurements. So some learning objectives here we're going to touch on. So first, recognizing when and how to use terrestrial laser scanning to gather those field measurements. Second, knowing when and how to employ mobile scanners to take field measurements. Third, understanding the role that point clouds play in displaying data in a usable form. And then finally, number four, becoming familiar with techniques for drafting and modeling as-built scope items in AutoCAD, Revit, and other BIM software. So we're going to cover three major areas here as kind of just mentioned. First, that would be laser scanning. Second, getting into point clouds. And then finally, BIM or building information modeling. And so throughout the presentation, we're going to have a series of polls in which I'm going to ask you all a multiple choice question and ask that you type your answers in the chat. If you could please hold all the questions if possible until the end. We'll have a Q&A section at that time and we can open it up for questions if you have any for me. You can put some questions in the chat though if they pop into your mind kind of as we go along here. But before we do get started with section one, let's start off with our first poll. So how do you generate your as-built plans? So A, you create them yourself, or do you B, you have an internal team that creates them, or C, you partner with an as-built firm? I'll give you guys a few moments to put some answers in the chat and we'll just kind of quickly take a look before moving on. I see some early answers, creating them yourself, using as-built firms, A, B, and C, little bit of all of them, whatever works, and for the moment. Cool. Yeah, it seems like creating them yourself is kind of the main consensus there, but we got some other answers kind of trickling in there. But thank you so much. Feel free to keep answering that question if you're logging on still, but I'm going to keep moving forward here. So let's get started with section one, laser scanning. So updating or even replacing a proven method for doing something by utilizing the newest technology is certainly not easy, no matter what industry you're in. The first step that you do take is the most important one, adopting that change. And the rest is just hard work and diligence. Even though it may be difficult to transition, making that change to laser scanning as a survey method provides you with fast data acquisition, much faster than doing it the old school way with, tape and disto. Provides you with more accurate, or it's more accurate than any measurements that can be taken by hand. It really dramatically reduces the odds of human error in the field as well. This technology can be purchased, rented, or contracted, so some options there. It's a thorough solution, allows surveyors to gather more data than needed to complete most projects, and finally provides a digital twin to kind of pull additional data down the line if the project ever needs to be revisited or additions need to be made to that scope of work. So what does LiDAR mean? We hear about it in this kind of tech in the news, maybe various articles about autonomous vehicles, stuff like that. And it's the same tech that's used to get survey data. It stems from the word radar, of course, which stands for radio detection and ranging. That's a much older technology, as we know, but it does still work in the same way. So LiDAR is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. Each one of those illuminations can be considered a measurement, and then each single measurement is logged. And throughout the course of the scan, millions of measurements are taken in all directions. So let's talk about some LiDAR scanners that are currently used for architecture, engineering, and construction. So when we need very accurate measurements or a lot of intricate detail captured for like historical projects, structural or engineering analysis, maybe prefab projects, we go to our favorite terrestrial scanner, and that is the Leica RTC 360. So even though this needs to be set up on a tripod, the individual scan times for the RTC 360 are relatively short compared to the other terrestrial scanners, making it the fastest terrestrial option out there. The iPad app also helps make sure that you can check your point clouds before leaving the job site. That's huge. The RTC 360 is extremely precise and gathers so much data that the point cloud files can actually be over 500 gigs sometimes. Oops, back. Whether we use the onboard camera to make a colored point cloud or not, we always get very dense, very accurate data that allows us to draft and model ornamental detail, pipe valves, other intricate details with precision. Because our final data is made up of hundreds or even thousands of scans sometimes, it makes it ideal for the starting and stopping sometimes required in busy spaces like hotels, shopping malls, industrial spaces, stuff like that. So with the RTC 360, you can scan up to 100,000 square feet in mere hours. And of course, this does vary by construction type and density. This one costs about $78,000, so it's definitely not on the cheap side. And that includes software. And then in the next slide, we'll see a short video of a scan that's taken with this scanner. So while our other scanners can be moved while they're operating, the RTC 360 needs to be placed in multiple positions all over the building to get a full set of measurements for our plans. Each red dot that you see here in the video is a place where we strategically position the scanner to gather the black and white data that you see. Even though we didn't use the camera for this data, you can see how much detail we're able to get using that black and white measurements method. Each black and white point or pixel is a representation of an actual laser measurement, accurately down to less than 2 millimeters. This means that the entire 3D picture you're looking at is dimensionally accurate. And then for this particular project, we use this data to help an architect identify floor sagging, wall sagging, as well as other structural issues before a major remodel. This was a 100-plus-year-old casino in Colorado. And so just for reference here, this was the final result of a project completed using the RTC 360. This was a Revit model of the Olympia Hotel at Capitol Lake in Washington. And here's that same property that I just mentioned on the other side, the other slide, showing the point cloud layered underneath the Revit model. This was 178,000 square feet. And I believe we modeled it in something like 176 total hours in Revit. So we've chatted a bit about terrestrial or stationary scanners. Now let's dive into a couple of our most commonly used mobile scanners. Those would be the GeoSlam Zeb Horizon and Zeb Revo. So some general points regarding mobile scanning and processing. First, using a mobile scanner is definitely preferable if you need accuracy. You're always going to need accuracy, right? But your time on site might be limited, so you want to use that type of mobile scanner. Since most individual scans take only 15 to 45 minutes, we certainly recommend that you process the scan on site. That way you're checking your results before you leave. Once the scan is complete, you need to use the SLAM algorithm software, which interprets all the measurement and movement data from the scanner to produce the 3D point cloud. And then after the SLAM algorithm produces the 3D point cloud, you then proceed to review the point cloud to ensure accuracy. Most errors in scanning or processing can really be spotted pretty quickly, and actions such as rescanning can be taken to ensure the overall accuracy of your project when the time comes to draft or model. We'll actually touch on these points, these kind of point cloud errors, a little bit later as well. So this is what point cloud data looks like in plan view. You can see that even though there's no photo-based colorization of the points, these points are colored on what you call a height ramp, where points at different heights are shown as different colors on a spectrum, which you can see on the left. Red is a lower height, blue is high, or yeah, red is lower, blue is higher. Coloring the points this way makes it easier to kind of see those important features in the point cloud, even without the photo colorization. So there's two types of GeoSLAM mobile scanners, the Horizon and the Revo, as I mentioned before. So the Horizon scanner, as shown in this picture, is one of our favorites. The scanner reduces the time spent on site by up to 90% compared to terrestrial scanning. It can collect 300,000 points per second with a 6 millimeter accuracy, and it covers a range of about 100 meters. You can pretty much use this to scan anything that's visible, of course. We've used this to scan single family residences, commercial buildings under 50,000 square feet-ish, restaurants, retail buildings, warehouses. You can scan up to 50,000 square feet in mere hours. And this obviously varies by construction type and density. And this scanner costs about 45,000, including the software. Then here's an example of a project that we scan using Horizon. This is a 9,000 square feet single family residence located in Washington, D.C. This client requested what we call our remodel package, which includes floor plans, roof plans, exterior elevations, and then still photos. It took about 6.5 hours to scan, so not too time consuming. And then the estimated ArchiCAD, we modeled this one in ArchiCAD. This took about 36 hours to finish up. And now the other one, the other mobile scanner, the Revo, and just like the Horizon, it reduces the scanning time by 90% compared to terrestrial. This scanner collects 43,000 points per second with a 6 millimeter accuracy. And then again, like the Horizon, you can scan up to about 50,000 square feet in hours, varies by construction type and density. And this scanner is a little bit cheaper at about $33,000 plus software. So here's an example of a point cloud for a single family residence that we scanned using the Zeb Revo. This was a 6,600 square foot single family residence in Auburn, Washington. This was a Revit model that included, of course, floor plans, roof plans. We did an electrical plan as well, exterior elevations, and still photos. And then here's an example of a mixed use project that we scanned using the Revo. This is a 27,000 square foot building located in Seattle, and the client requested floor plans, roof plans, exterior elevations, RCPs, and interior elevations. And so this image is what the RCP ended up looking like. And as you can tell, it was a super dense project. Took us about 8 hours to scan the whole space, and then 36 hours to draft the project in CAD. And so next up, we have section 2, which gets into point clouds. So reviewing your data well before attempting to create that set of as-built plans from a point cloud is a must. If there's any kind of errors when your cloud is, or where your cloud is, which do happen, using that bad data can either stop you in your tracks later on when you're drafting or modeling, or even worse, just simply result in a complete incorrect set of as-builts. So once your scan is processed, you'll need to review the output. Did you cover all the areas? Are there any flaws or errors? And have you ensured that there's no drifting? And we'll touch on drifting in a few minutes here. So most scanners have a range of hundreds of feet, which can produce a lot of data outside your project scope that you don't even really need. So you may need to clip or crop your point cloud to reduce that file size by getting rid of that unwanted data before really getting started. If you have to produce multiple point clouds for a larger complex project, it'll be important to get comfortable with point cloud software that'll allow you to merge or register your clouds and more easily manage that data. So to reiterate, since the scanners have such a wide range, you're going to want to trim or crop your point clouds to eliminate that excess data from long range scanners. For large projects, utilize point cloud software to merge and streamline data management. And then much like the traditional method of hand sketching and measuring, properly scanning a structure takes a lot of practice to do it correctly and efficiently. And then once you're practiced with scanning and kind of know what to look for as far as errors are concerned, you'll have the most reliable version of data that you can possibly gather in the field. You can be confident that the as-built plans you create will be fully accurate and ensure a smooth and safe renovation as it progresses. So some trouble points kind of continued when you're kind of scanning attics, foundations, large sites, maybe multi-level structures. You may run into issues getting all your data to kind of fit together. Areas that potentially, maybe they're hard to access. They have lots of reflective surfaces, mirrors, um, or maybe they have fewer unique features like office hallways or open empty spaces, like you kind of see in the photo there. Those can all pose a challenge. So processing requires all areas have data connecting one area to the other so they can be properly kind of glued together. Mirrors, moving objects, etc. Those can kind of trick the process and therefore give you a bad output. The screenshot you see here is of a multi-level structure and is a space with kind of those fewer unique features like we mentioned. And additionally, it's an open, empty space. And so this did pose a challenge while we were on site. So make sure to look for any drifting, which can occur when the software has trouble putting all the point clouds together, all the points together. And you kind of see that in the photo there. If this occurs, then you can try some reprocessing options or simply do a complete rescan, which can happen. Drifting includes reflection noise, other data noise, needing to use other devices for control on the larger buildings, internal scanning errors, mirrors reflecting data, and just duplicate data. It's important to keep an eye out for multiple types of drifting inside and outside of the building. And like I mentioned, it can be common with mobile scanners and occurs for several different reasons like we just listed, but determining which of those reasons ahead of time, once you see it, that's definitely helpful before attempting to maybe reprocess or even just rescan. So now that you've collected the data using the methods we discussed earlier, it's time to create the actual plan sets. However, before we move forward to section 3, revolving around BIM, Building Information Modeling, I'd like to pause here for our next poll. So I'm curious, which software do you work in? If you could put your answers in the chat, that'd be great. So A, AutoCAD. You plan to always work in AutoCAD. B, AutoCAD, but you're kind of looking into maybe transitioning into something else. C, Revit, D, ArchiCAD, or E, SketchUp. So I see some answers already getting punched in, a lot of A and C. So AutoCAD and Revit, obviously those are kind of two of the more common ones. So not all of that of a surprise here, but I do see some SketchUp answers. So it sounds like, I mean, even people are potentially kind of moving into the more modeling side of things. And yes, Jacob, I wanted to actually mention F, other. And if you have another that you use, throw it in there. G, Rhino. We're going to get to Z by the time we're done here. But yeah, obviously these are the most common. So thank you for throwing in your answers. Keep them coming. We'll take a look as we keep moving on here. So let's dive into drafting from that point cloud. So when you're drafting from a point cloud, the first thing you'll need to do is get into a drawing environment. So point clouds can be imported directly into AutoCAD or Revit, as well as other architectural software. If you use Autodesk products, you'll need to use an application called Recap to prepare that point cloud to ensure it works within their entire software suite. Drafting from a point cloud in AutoCAD is mostly straightforward, but it does take some getting used to. Point clouds are ideal as-built data sets for creating Revit models, but sometimes the Revit point cloud tools can feel a bit lacking. So let's first talk about CAD drafting from a point cloud, specifically in plan view. So in the image here is an example of a slice of a point cloud in plan view. So regardless of how you get your survey measurements, it's good to start any as-built plan by starting with the floor plan, of course. So when drafting in CAD from a point cloud, you want to ensure that your cloud is positioned orthogonally so that you can use that ortho function in CAD to easily draw your lines. If you're going to work on elevations or need to extract any heights from the point cloud, it's also good to position the point cloud in the Z-axis. Typically, we start by lining up the finished floor surface of that first floor at a 0, 0 datum point. Once you have that point cloud well positioned to begin your drafting, you should be able to derive all the walls, doors, door swings, and any other visible architectural and structural information that you need right there from the point cloud. Some items like windows can pose some difficulties when trying to extract that width and height information. But with diligence and practice at manipulating the point cloud, it does get easier. And then some scanners will not pick up smaller items, especially if they're flush with the walls or ceilings, maybe like can lighting, electrical switches, outlets, things like that. So trying to locate those in the cloud can be really time consuming. And in that case, it's quite often just better to use more traditional measurement tools while in the field and just sketch and measure those items. So now let's get into drafting other views such as an elevation from the cloud. So when you're working in a 2D drafting environment, it's not only important to have your point cloud well oriented in the drafting space, but you'll need to be well practiced at manipulating that coordinate system views in the point cloud section. So once you do, you'll see this is where there's a huge advantage in having a complete point cloud for drafting, provided that you were able to access the roof and scanning, you will have a complete picture of not only the roof behavior, but also every height that you're going to need to properly draft that roof, exterior elevations, and potentially any section cuts that you might need. And then as with electrical and RCP components, sometimes it's beneficial to revert to traditional methods, like I mentioned, to just kind of sketch elevation ornaments, ornamentation that you're going to need to include in your drafting. So now that you've seen how we set up the point cloud in AutoCAD for drafting, let's also examine how this setup works in Revit. So the level of development system was created for the AEC community to put standards on BIM drawings. It describes the different ways in which 3D objects can represent existing or design elements in a BIM model, with level 100, of course, being the lowest, meaning you just kind of mass your objects roughly, and then all the way up to level 500, which is the highest, being so detailed and exact that you're essentially building like a virtual version of the structure. When modeling as-built plans, LOD 200 is kind of the most applicable range there, since you're kind of assessing a structure that has been built from the outside, with many interstitial spaces being inaccessible. The specific construction of many architectural and structural elements usually can't be determined, which is required for models in LOD 300 and above. So, similar to drafting in AutoCAD, the first thing you need to do to work with a point cloud in Revit is make sure it's in recap project format for use with Autodesk products. Using that point cloud to guide modeling in 3D can be more complex than drafting in 2D. However, the benefits of having all the elements of a building related to each other in a set of 3D drawings can be valuable to your design and planning process, because you can see the way things interact with each other in a way that you can't really see with a set of 2D drawings. Viewing that point cloud and model in 3D provides even more information about how structure, MEP systems, and architecture interact. more than you really would find with a model alone. And then modeling an as-built in Revit may seem overwhelming at first, but a solid order of operations for creating a usable Revit model will go a long way. So first, let's talk about uh, modeling the plan view items from a cloud in Revit. So when you're modeling in Revit from a point cloud, you want to ensure that your cloud is positioned orthogonally, just like with CAD in plan view, so that you can use that ortho function to place your walls. And then set the finished floor to your 0, 0 level, and then create set all other levels to key features in the point cloud. And then once you're done setting the finished floor, you can start adjusting your view range, view depths in your plan views to add wall, door, and window families in the places indicated by the point cloud. So now going from plan view into modeling vertical information. So as with AutoCAD, this is where there's a huge advantage in having that complete point cloud for modeling. Drawing sections, adjusting section depth is super crucial to viewing point clouds effectively when you're adjusting window heights, door heights, creating roofs, stuff like that. Practice patience, of course. Roofs are tough to model, but even more so when you want them to, to accurately match a point cloud. So there's some advantages to having a BIM as built, which some may not even know. Sometimes a three-dimensional model is only really considered for a presentation type, for design purposes, but it can really be useful as an as built as well. So the as built BIM model can be viewed in multiple phases, so you can easily switch between existing demo, proposed, and alternative proposed phases. When you have a BIM model, moving from the design phase to the construction documents phase of a project is far more efficient. Also, having an as-built BIM model can make it easier to understand a project that you haven't maybe visited yourself, since you can cut sections, view interior spaces, review roof massing, and all of that being done in 3D. And then some believe Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to the owner or even planning departments. So now it is time for our last poll for the day before the Q&A session. And what is the most important factor to you when obtaining your as-built plans? A, quality and accuracy. B, timeliness or turnaround time. C, efficiency. Or D, cost. And feel free to throw your answers in there. I would imagine we're going to see the one letter the most, one of those answers the most, but we'll find out here in a sec. Quality and accuracy, that's what I was expecting. But I see efficiency kind of sprinkled in there too, which makes sense. They're all important, right? We understand that, but I think quality probably trumps all. Cool. Well, thank you guys for throwing in your answers. I see a few more kind of thrown in there at the end there, but I think that should do it. Let's see. Yeah, we're in the Q&A portion. I actually wanted to skip ahead one slide here real quick, just so I don't forget. And obviously, thank you guys for attending. Hope you're able to gain some insight here. Perhaps I'll get the chance to collaborate with some of you in the future. But lastly, I really wanted to mention that our marketing team or I will be in touch with our raffle winner, and that's that Paris Skyline Lego set that you see there. So good luck. We'll probably be in touch. I don't know, Amber, what you think? Maybe in the next few days, a week at most. So
yeah, within a week is definitely at the most.
Yes, perfect. That's what I thought. So now let's go to the Q&A. I had one eye on the chat as we were kind of moving through that. I don't know if I saw any questions pop up then, which is totally fine. But if anyone had any questions now, for me, I can certainly, how much time we got? We got plenty of time. So I'm happy to answer any questions you have. I see one coming in. Yeah, go ahead.
Yeah, Will with Winnick Architects. Quick question for you guys.
Yeah.
So we do also have a scanner as well, Matterport.
Oh.
And
Okay.
we use it a lot. And the only thing is that the downside about it, it's like on your handheld device, you did have a scanner that scans the roof. How do you scan the roof? Do you like literally have to climb on it and scan it? Or
Yeah.
how,
So
how
safety first, right? We certainly don't send our surveyors up on, super high pitched or, roofs that could pose a safety hazard for sure. But yeah, if it's safe, we get a ladder if obviously necessary and climb up there and do a full scan.
right,
And sometimes to maybe circumvent that, if it's not accessible, it's also doable to get up into the attic space and get the underside of the roof. So that way you can at least get like reliable pitch information and maybe hip and valley and ridge
Mhm.
locations and kind of build it that way.
Yeah,
But
which makes
that's
sense.
less ideal for sure.
Great. And one other question I had is, I
Yeah.
know in the scanner on the exterior, we can only do, well, like we can only limit the exterior because of the sunlight and it just goes off into, like infinite, because laser scanning. So then we have to switch on to the 360 mode instead of the 3D point laser scanner. How does your, these other handheld devices work?
Yeah, sure. That's not an issue for these. We have Matterport scanners. We
Mhm.
don't use them for scanning purposes, for drafting or modeling. We
Right,
simply use them for like tour
right.
purposes. Um, I know that the Matterport like spits out a point cloud and all that, and you could kind of extrapolate that data into a plan or a model, but we don't trust it
Got
as
it.
much as these.
Mhm.
Um, but yeah, light, sunlight, or even lack thereof,
Mhm.
usually is not an issue. I think if that was your main question.
Yeah, because on ours, the sunlight actually like you can't really scan the light, so it has to be in interior scanning. So that's a
Yeah,
little
I
complicated
know the
to
Matterport. Yeah, the Matterport scanning on the outside can be troublesome for the
right.
reasons you mentioned, but also it doesn't. It only goes so far. The technology, like the measurements taken, it's not able to. The algorithm isn't able to stitch that all together as well as being inside, of course.
Sure, of course. And sorry, one last question. Where
Yeah,
is it
no, keep them
possible
coming.
to rent these handheld devices, or do we have to hire some sort of a like your firm or your company? We have to hire you guys to do this, or can we just rent them?
Yeah, good question. So you can purchase them. There are companies that rent these out as well, and then there's as-built firms like us who do this every day, all year
Right.
long. So, and that's our fleet. We've got several different scanners, some that we didn't even touch on here in this presentation, but certainly the ones that we did. So there's options. Yeah,
Great. All right. Thank you.
yeah. No, thanks for all the questions. Any other questions out there? Otherwise, we can
I've
give
got
back about 20 minutes of
I've got
your
a
guys' time
question
now.
for you.
Go ahead, Jacob. Yeah.
I could see that, see the appeal for like a historic hotel, kind of, 30,000 square feet or something like that. Is
Yeah.
there a mode or an option for something like, like a smaller single family home where you don't need to have every eave kind of detailed to the T's? Is there kind of in that last slide you mentioned, efficiency. Um,
Yeah.
what's kind of your experience in terms of the scale needed to make this technology worthwhile, I guess, on a project?
Yeah, I mean, that's a tough question, but I mean, certainly there are scanners that are overkill, right? Like for the property that you may be working on. The RTC 360 that we mentioned first might not be it might be too much for a small single family residence that doesn't have all those like intricate details. Now in Santa Barbara, I know a lot of the stuff is historic, so maybe something like that would be useful. Um, Scanning in general, we started out more with the mobile scanner, and the biggest benefit that I always found having when I started here, we were doing it all old school. So it's transitioned over time. But the biggest benefit I saw was for the homeowner or whoever the tenant was. Um, we would be there a day, maybe more, on a small single family residence, and now we're there for an hour. People don't want us there, in their personal space, you know, more than we have to be. Um, and then as mentioned kind of in the presentation, that the removal of the need to go back. I'm sure many of you who do it by hand, we did it by hand for a long, long time. We'd have to go back on site fairly often, because we just forgot one key measurement, and that was just like such a gut punch. Not just for us, but also for the homeowner, I'm sure. And so this has kind of removed all of that. I don't know if that answers your question directly, but I do think that there's better scanners for different property types, but I don't know that there is a property type or project that a scanner isn't good for at this point, having seen both sides of it. Cool. Yeah, thanks. Good question. Any others?
I had a question.
Mira, I don't know if yeah, go ahead, Bonnie.
You get this really accurate scan, and then you have to, it seems like, make some judgments when you model it. If a building isn't quite true, I'm just wondering, do you pretty much always just model it orthogonally, or is there a point where you try to actually model those kind of?
Yeah, good question. We actually this does come up from time to time, and it's funny you asked, because this came up just last week. We had a building that was just barely off 90, but using other information, like we were lucky enough to have a legal land survey at our disposal, satellite views, things like that, and it was just clear that kind of supported what our point cloud was telling us, that it was off 90. And so we I forget if we drafted that one or modeled it, but we produced it as such. So it certainly happens, and we don't assume 90, in all cases, that's for sure.
Thanks.
Any other questions? I appreciate it. These are all good questions. But Mira, I'm not sure if you had other announcements, chapter announcements, or something that you wanted to touch on before we head out here. Well, if you have questions, you can reach out to me. Maybe Amber, you and I can put my information in the chat there. Can make myself more than available to answer any questions that you might have that kind of come to your mind after we hop off here.
Yeah, I have nothing to add. So if no one has
Okay.
any other questions, they can email you, and I think it's safe to wrap this up.
Perfect. Well, thank you guys. I really appreciate it. Have a great Wednesday. And yeah, we'll be in touch with that raffle winner soon.